This is Gagan Girotra, IIT Roorkee class of 2000, and I am Calcutta class of 2005.
Welcome to our first class on time and work. Now, time and work, you will broadly see problems of two types, all right? The first kind of problems, as you can see on the left hand side of this page, 4 men can dig 5 holes in 6 days. The question is, how many holes can 8 men dig in 12 days? Okay, that's the question type 1. Question type 2, you can see on the right hand side of this page. A alone can dig a hole in 5 days, B alone can dig the same hole in 10 days. If we hire both A and B to dig this hole, how many days will it take them? Alright, now let's attack the question type 1 now. Now before we get there, let me just clarify a few concepts for you. Alright, now clearly what you can see, what you notice is that there are 4 men who are digging 5 holes in 6 days. Yeah, and then the question is, how many holes can 8 men dig? So clearly the assumption that the tacit assumption that we see here is that men have equal output. So it doesn't matter if I pick the first man or the second man or the third man, they all have equal output. That's exactly why I'm able to talk about them in numbers, right? All right. Now let's continue on this discussion. Now the basic assumption that was made in the first problem was that the work done is clearly proportional to the number of individuals on the job, right? So if let's say there is 1 man who can dig 1 hole, clearly if I double the number of men, if I make it 2 men, they should be able to dig 2 holes in the same time, right? So work done is proportional to the number of people on the job given that everything else is constant. Okay, that's the first assumption that we have made. The second assumption that we make is that the work done is also proportional to the time that these individuals have on the job given everything else is the same, right? So if let's say there is n number of individuals who are able to dig 1 hole in 1 day, if I give them 2 days, the same number of individuals, they should be able to dig 2 holes, right? So clearly work done is proportional to the number of individuals on the job. The work done is also proportional to the time that they have on the job. Now if I combine both of these assumptions, I get work done is proportional to the number of people on the job and the time that they get on the job, which means that if I remove this proportionality and replace it with an equality, I will need a constant here. Yeah. So let's understand what this constant is. This constant is work done upon the number of people upon time, right? So if I were to write this constant in simple running English, this is work done per individual, yeah, per unit time. Excuse my writing, huh? So what exactly does this mean? Work done per individual per unit time being constant. This means that individual output or individual productivity is constant, right? Which brings me back to my original assumption that if I have 4 people, right, it doesn't matter if I pick the first one or the second one or the fourth one, they will all be able to produce the same amount of work in the given time, right? So that's exactly what we mean by productivity across individuals being constant. Okay, now what does this tell me for my problem solving? This tells me that let's say there are 2 situations, situation 1 and situation 2. The amount of work done that I get done in the situation 1 by n1 people in t1 time, and let's say in situation 2 I got the amount of work done is w2 being done by n2 people in t2 time. This tells me that the relationship w1 upon n1 t1 should be equal to w2 upon n2 t2, right? So with this basic theory in place, now we should be in a position to answer questions like problem number 1. So we have 4 men digging 5 holes in 6 days. So clearly the situation 1 is the output or the work done is you have 5 holes, right? How many people do you have? Individuals on the job? We got 4 men. Okay, and how much time do they have on the job? The time that they have on the job is 6 days. Yeah. And situation 2, we have 8 men digging and we have 12 days for them to dig. The question is how many holes? So clearly W1 upon N1 T1 equals W2 upon N2 T2. So W1 is 5 holes dug by 4 men in 6 days should be equal to X holes dug by 8 men in 12 days. So X is 5 times 8 times 12 on 4 and 6. So we can just cancel these out for 2 and 2. So we have 20 holes, right? All right. Now for the problem type 2, so I hope you can differentiate now between the first kind of a problem and the second kind of a problem. The first problem has all these people with equal productivity. The second problem says A alone can dig a hole in 5 days and B alone can dig the same hole in 10 days. Yeah. So clearly A and B, two different individuals, two different capabilities, right? So clearly we cannot use W1 upon N1 T1 here, right? Because A's productivity constant is different from B's productivity constant. Yeah. So what we will do here is, if A can finish the job in 5 days, right? Clearly the productivity of A per unit time will be 1/5 work getting done per day, right? So just look at this relationship. The relationship between the time and the productivity is that they are reciprocals of each other. So if it takes me 5 days to get the job done, one day it'll take me in one day I'll be able to do 1/5 of the job. Likewise for B, if it takes B 10 days to get the job done, B will be doing 1/10 of the work in one day, right? So if I have A and B working together, clearly in one day I will be able to get both of them to do 1/5 plus 1/10 of the job, right? So this is going to be the combined productivity per day. And if I add them, I get LCM 10, numerator 2 plus 1, which is equal to 3/10 per day. So it is clear that if A and B are working together, they are finishing 3/10 of the job in one day, right? And we had established that the time that they take and the productivity per day are reciprocals of each other. So clearly the time that A and B combined will take to finish the job is going to be the reciprocal of this 10 upon 3 days, right? So guys, I hope this is clear that all the time and work is going to be based on these two principles, where you either have groups of same productivity where we are going to use W1 upon N1 T1 equals W2 upon N2 T2, or you would have individuals with different productivities where we will use their productivity per unit time, right? And we will do all the operations on the productivity per unit time and not the days that they do that they take to finish the job.
Thanks for watching the video. You can give your feedback in the comments section below. Please click the like button if you thought the video was helpful. For lesson updates, you may subscribe to my YouTube channel People Plus, or you may read my blogs at peopleprep.com, or you can directly connect to us through our Facebook page @PeoplePlus, or you can email to me at gagan@peopleplus.com. Thank you.